The historical ledger calls it a triumph of the American spirit. The official narrative, repeated by every mainstream documentary, expects you to marvel at the machines. They tell you it took exactly 410 days to stack 57,000 tons of steel into the sky. They want you to look at the speed, but they desperately want to hide the kinetic, financial, and biological cost of bending the laws of physics to meet a corporate deadline. Building 4.5 stories a week is not an architectural miracle. It is a thermodynamic and biological deficit. You do not build a 102-story skyscraper in 13 months with pure enthusiasm. You do it by creating a brutal vertical assembly line that operates on a 0% margin of error. It requires 38 riveting gangs working in freezing winds and blistering heat, tossing red-hot iron over open air with absolutely zero safety nets. The Empire State Building wasn't just built. It was a corporate matrix born from the stock market crash of 1929. A machine that squeezed 7 million man-hours out of biological units pushed entirely beyond their mechanical limits. At the TitanMetrics Audit Desk, we do not romanticize the steel. We audit the supply chain, the pneumatic friction, the wind shear, and the human breakdown. Open the ledger.
Mainstream history channels will show you pictures of cranes, claiming that technology alone won the race for the sky. This is a fundamental misunderstanding of structural logistics and corporate panic. To understand the impossible speed of the Empire State Building, you must audit the financial matrix of 1929. Former General Motors executive John J. Raskob wanted to build the tallest structure on Earth. But in October 1929, the stock market crashed, erasing billions of dollars. Suddenly, this was no longer a vanity project. It was a desperate race against bankruptcy. With a staggering $27 million mortgage from the Metropolitan Life Insurance Company hanging over their heads, every single day of construction cost the syndicate thousands of dollars in interest. The building had to open by May 1, 1931, or the financial collapse would be absolute. Before a single beam of steel could rise, the Starrett Brothers and Eakin Corporation faced a colossal volumetric paradox. The site they purchased was not empty. It held the original Waldorf Astoria Hotel, a massive 13-story structure containing millions of tons of heavy stone, brick, and iron. It had to vanish. The logistics of demolition are governed by mass and gravity. To clear the site, workers manually dismantled the Grand Hotel in just 5 months. They generated 16,000 truckloads of dead-weight debris. Where does a city put a mountain of crushed stone? They dumped it into the Atlantic Ocean. They literally towed the old world out to sea to make room for the new one.
But clearing the site only introduced a more terrifying mathematical fact. Manhattan Island had 0 storage space. You cannot dump 10 million bricks and 57,000 tons of steel onto 34th Street. The streets were an absolute suffocating gridlock. If a single delivery truck was delayed by 5 minutes, the entire kinetic chain of the construction would collapse. So they didn't treat the site as a construction zone. They weaponized logistics. They created just-in-time manufacturing decades before the term existed. They turned the building into an autonomous vertical factory. Steel beams were forged in the blast furnaces of Pennsylvania by the American Bridge Company. Still warm from the fire, they were loaded onto trains, transferred to barges, loaded onto trucks, and driven directly into the epicenter of Manhattan. The moment a truck arrived, a massive derrick crane ripped the steel from the bed and hoisted it into the sky. It never touched the ground.
But how do you lift steel past the 30th floor? A street crane cannot reach that high. The engineers ordered 11 custom-built derrick cranes from Clyde Ironworks in Minnesota. These cranes were unbolted, hoisted up the newly built steel skeleton by other cranes, and rebolted to higher floors. The building was literally pulling itself upward by its own spine. Within 80 hours of being liquid metal in a Pennsylvania furnace, that exact beam was riveted into the steel skeleton a quarter mile above the earth. The building was swallowing the material in real time.
Moving steel is a matter of heavy cranes, but steel is only the skeleton. What about the flesh? To enclose the building, the architects required 10 million bricks, 200,000 cubic feet of Indiana limestone, and 62,000 cubic yards of concrete. This represents thousands of tons of dead weight. You cannot move 10 million bricks up 100 flights of stairs using men with wheelbarrows. The biological fatigue would stall the project in days. The elevators would be hopelessly congested. The entire matrix would seize up. To achieve 4.5 floors a week, the engineers executed a stroke of logistical madness. They installed an industrial narrow-gauge railway system inside the building itself. Tracks were laid on every active floor. Men pushed heavy iron mining carts, each loaded with 8 times more material than a standard wheelbarrow, navigating a dizzying maze of open steel girders and deadly drop-offs. But how do you get a train cart full of bricks from the ground to the 50th floor? The central elevator shafts were completed first, acting as the primary vertical arteries of the matrix. A delivery truck would arrive on 34th Street and dump its load of bricks straight down a wooden chute into the basement. In the dark, the bricks fell into a massive metal hopper, which funneled them directly into an iron rail cart. The loaded cart was rolled into a temporary high-speed construction hoist. It was fired vertically up the dark shaft at hundreds of feet per minute and rolled out onto the active floor. The cart rolled along the temporary rails to the bricklayers, who were waiting to instantly cement them into the outer walls. The empty cart was sent back down. It was a continuous, unbroken kinetic loop, operating with ruthless mechanical efficiency. But a mechanical assembly line is predictable. Machines follow the laws of physics. The real vulnerability of the Starrett Brothers matrix was the engine required to fuse the steel together, the most fragile engine on the site.
To hold 57,000 tons of steel together in hurricane-force winds, you cannot use bolts. You must use thermal expansion. You need rivets. And to drive a rivet, you need a 4-man gang, operating in a synchronized dance of extreme thermal and kinetic violence. Let us audit the physics of a riveting gang. You have the heater, the catcher, the bucker-up, and the driver. The operation begins with the heater. The heater stands on a wooden plank suspended over a terrifying drop. His job is to crank a portable coal forge until the temperature reaches roughly 1,900 degrees Fahrenheit. He takes a solid steel plug, buries it in the coals until it glows blindingly white hot, pulls it out with heavy iron tongs, and then, defying all modern safety protocols, he throws it. He literally throws a piece of scorching near-liquid metal 50 feet across the open sky, cutting through the freezing winds of the Manhattan winter. Waiting on a steel beam no wider than a dinner plate is the catcher. Using a battered tin can, he catches the red-hot projectile mid-air. If he misses, a lump of molten steel drops onto the crowded streets of New York below. If he catches it, he uses tongs to jam the scorching metal into the drilled hole connecting 2 thick steel plates. And the final brutal phase begins. Instantly, the bucker-up presses a heavy iron bar against the back of the rivet to hold it in place. Simultaneously, the driver unleashes a 35-pound Chicago pneumatic hammer against the front. Operating on 120 pounds of compressed air per square inch, the heavy pneumatic hammer strikes the glowing metal at over 1,000 blows per minute,
crushing the tip into a flat mushroom head. This is not just about reshaping metal, it is about thermodynamics. As the red-hot rivet cools in the freezing air, the metal physically shrinks. This thermodynamic contraction locks the two steel beams together with immense permanent crushing force. But this kinetic violence demands a biological toll.
The kinetic trauma transferred from the heavy pneumatic hammer directly into the driver's skeletal system is catastrophic. Over a period of 13 months, this sustained, violent vibration induces severe hand-arm vibration syndrome. The microfractures in their bones, the nerve damage, and the destruction of the vascular tissue became permanent biological damage. The acoustic violence alone was catastrophic. 38,000 pneumatic impacts per minute, echoing through the unyielding steel skeleton, ruptured eardrums, and left a generation of workers with profound, permanent hearing loss. They did this over and over and over again. 730 rivets a day per gang, 38 gangs, 2.5 million rivets in total. To achieve this, the corporation heavily recruited from the Kanawake Mohawk community. Mainstream history romanticizes these ironworkers, claiming they had a genetic lack of fear for heights. At the TitanMetrics Audit desk, we read the psychological ledger. 23 years earlier, in 1907, a bridge in Quebec collapsed, killing 33 Mohawk ironworkers. It was a tragedy that forged an iron oath in their community: never let fear own the sky. The corporation did not hire them for genetics. They hired them because their collective trauma had weaponized their bravery. They were the perfect biological components for an impossible machine. The official record marvels at the speed, but a forensic audit reveals the truth. The speed was achieved by systematically burning through the biological limits of the workforce.
You cannot move at the speed of corporate greed if you are worried about physics or biology. If you look closely at the archival photographs, the one shot by Lewis Hine, showing workers eating lunch on a suspended steel beam high above the city, you will notice a terrifying absence of equipment. There are no hard hats. The hard hat would not be mandated on a major project until the construction of the Hoover Dam a year later. There are no safety harnesses. There are no lanyards. And most chillingly, there were no safety nets. When the Golden Gate Bridge was built a few years later, a safety net saved 19 men. But the Starrett Brothers Corporation ran the math. Hanging safety nets beneath the riveting gangs and constantly moving them up floor by floor would slow down the vertical assembly line. It was cheaper, mathematically and operationally, to accept the risk of human gravity than it was to delay the project. To keep the men working without pause, the corporation built 5 cafeterias on the unfinished floors. Workers could buy a hot meal for 40 cents without ever descending to street level. Historians call this an innovation in worker comfort. We call it what it was: a biological refueling station designed solely to prevent the kinetic conveyor belt from stopping. Mainstream historians will aggressively defend the corporation here. They will point to the official ledger, which states that only 5 to 6 men died during the entire 410-day construction. They compare this to the 96 dead at the Hoover Dam and call the Empire State Building an incredible safety record. At the TitanMetrics Audit desk, we understand corporate obfuscation. When you have 3,400 exhausted men working on slick, freezing steel, operating heavy machinery over a quarter-mile drop without a single safety net, 5 deaths is a statistical impossibility. The corporate ledger utilized a grim loophole. They only counted bodies that died instantly on the concrete site. Newspapers of the era reported workers crushed by slipping derricks and asphyxiated in the deep bedrock foundations. But if a man fell, shattered his spine on a lower setback, and died in a hospital bed hours later, the corporate ledger reclassified the incident. It became a medical failure, not a construction death.
The true biological cost of the Empire State Building remains permanently hidden in redacted corporate archives. They pushed the human machine to the breaking point. But the greatest engineering lie of the entire project wasn't the speed. It was the absolute arrogant ignorance of aerodynamic physics at the very summit.
To support these structural audits, join the Oversight Committee below. Now let us audit the spire. When you look at the top of the Empire State Building, you see a 200-foot spire. The corporate investors, driven by a desperate ego war to beat Walter Chrysler's building for the title of the world's tallest structure, announced a revolutionary idea. The spire was designed as a mooring mast for transatlantic dirigibles. They told the public that wealthy passengers would board a Zeppelin in Paris, float across the ocean, dock directly on the 102nd floor, and take an elevator down to the streets of Manhattan. It was a brilliant public relations stunt, and it was a complete aerodynamic fraud. To design the steel skeleton, the corporation hired structural engineer Homer Gage Balcom. Balcom was the world authority on wind stress in tall structures. He installed testing equipment to measure wind pressure and sway at 1,000 feet in the air. Because of Balcom's data, the engineers knew exactly how the wind behaved at the summit, which means they knew docking an airship there was a physical impossibility. When wind hits a massive flat surface the size of the Empire State Building, it doesn't just go around it. Fluid dynamics dictate the creation of massive thermal updrafts and a highly destructive phenomenon known as vortex shedding. The air is violently forced straight up the sides of the structure, creating a chaotic, invisible hurricane of unpredictable kinetic energy exactly at the summit. Now imagine taking a 700-foot rigid airship, a massive duralumin skeleton filled with highly volatile hydrogen gas, and trying to tie it to a needle in the middle of a vortex using nothing but ropes while dangling a quarter-mile above the ground. It wasn't just dangerous, it was mathematically suicidal. They attempted it exactly once. In September 1931, a small dirigible tried to dock. The aerodynamic updrafts caught the tail of the airship, violently flipping it to a near vertical angle. The friction and wind shear nearly tore the hull apart. The docking procedure lasted exactly 3 minutes before the pilot aborted to save their lives. The mast was never used again. It was a 200-foot monument to corporate arrogance, built with zero regard for the actual laws of atmospheric physics, purely to win a measuring contest against Walter Chrysler. The official record wants you to look at the Manhattan skyline and see a miracle of speed and machines. But at TitanMetrics, we see the 410-day biological deficit. We see the thermal trauma of the riveting gangs, the acoustic violence, the obfuscated cost of zero safety nets, and the aerodynamic lie of the Zeppelin mast. The Empire State Building is a masterpiece of logistics, but it was achieved by treating human biology as a disposable resource in a corporate algorithm. When corporations ignore physics and human limits, structures get built faster. But what happens when that exact same corporate arrogance is applied to a project where failure isn't just a falling rivet, but the fracture of an entire continent? What happens when engineers try to build a canal by forcing human bodies to burn 6,000 calories a day in a tropical furnace, while trying to manipulate millions of tons of water with boiling concrete? The Panama Canal wasn't just a construction project, it was a thermodynamic nightmare. That file is on your screen right now. The ledger remains open.